End-to-end unsupervised learning of long-term 3D stable objects. 3D point cloud maps are one of the standard formats for vehicle localization. However, the raw maps may not be suitable for long-term localization, since they suffer from the flying ghost artifacts and they capture dynamic objects as static, for example parked cars. In this work, we are interested in identifying the long-term stable object in a given environment in unsupervised way. Our work is twofold. First, an unsupervised algorithm for point cloud labeling. Second, a regression network based on PointNet++ 4-point stability estimation. Our unsupervised auto-labeling has two parts. First, data preprocessing block by filtering the ground and outliers. Then, register the maps with respect to the first map. Second is the labeling algorithm, which assigns a spatiotemporal stability label for each point in a given reference map by exploiting the distance to the nearest neighbor points with respect to all other time slices of the environment. Our second contribution is a point-to-point regression model based on PointNet++. The network is trained on the stability labels. To address the imbalance in the continuous labels, we used a sample weighting approach, where the weight for each sample is based on the rarity of the label's value occurrence, which will help the model to estimate the rare cases. As a cost function for the regression model, we used a weighted root mean square error loss function. To evaluate our approach, we used 2 parking lot areas from the NCLT dataset, and we used 5 observations for each area taken at different times through the year. The results shows that the regression model trained on the unsupervised labels outperformed a binary classification model trained on a binary ground truth labels by large margin in multiple setups, where the regression model shows better spatial generalization when evaluating in unseen areas. Conclusion: long-term stable object classification is best performed by training a regression model on the stability scores followed by thresholding compared to directly training a binary classifier. To our best knowledge, this insight was not previously known in the literature for the problem of object stability, static or dynamic classification. Furthermore, the continuous labels are more suitable to indicate slowly moving objects because they are difficult to label as static or dynamic.